Okay. In this section, we're going to talk about logarithms. And first, I guess I need to start off with what we call exponential form. The exponential form of an expression would be when you have an exponent. Usually, an exponential, when it has a variable, means that the variable is the exponent. For example, I'll write it over here. If I had 7 to the x equals, I don't know, 150. X is my exponent, and that would be considered an exponential equation. But basically, if values are in exponential form, one of them is an exponent. All right? What our goal is to be able to solve for x. And I cannot solve for x when it's the power, or the exponent. I cannot divide by 7 and get rid of the 7. So I'm trying to undo x as a power. The inverse of that would be what I need to do to solve for x. So what is the inverse of an exponential? It would be a logarithm. This is what we call exponential form, and right now I want to show you what logarithmic form is. Log form, if I take this and just rewrite it in log form, it would of course start with the word log, L-O-G. Yeah, I guess I can use this. Now, very quickly, the 4 is my exponent. You may remember way back when you were first learning fractions, the name for the 3 is called the base. This is the base, and this is the exponent or power, and this is what it's equal to. All right, first rule. And I didn't leave room for this over here, so I'll try to write it over here. Rule number 1, if you can read this, the base is the base, or the base remains the base, whichever way you want to look at it. What that means is no matter which form I'm looking at, whatever was the base in one form stays the base in the other form. Now, in log form, how you word it is important because it tells you a lot. For example, in the first one, my base is 3. 3 is the base, 4 is the exponent. So if 3 is the base, when I write it in log form, 3 is still my base. So where do you write the base? You write it right down here. It is a subscript, which means it should be a little bit lower than the G, the L-O-G. Log base 3. Okay, rule number 2. And I'll put it right over here. Rule number 2 is the two numbers, I'm going to abbreviate, two numbers don't, pardon my messy writing, I should have done this ahead of time, don't stay together. Okay, what do I mean by that? Well, let's see. There's 1, 2, 3 values right here. The 3 and the 4 are together on the same side of the equal sign. When I want to change it to log form, then the 3 and 4 don't get to stay on the same side of the equal sign. So that's kind of a hint. If the 3 cannot be with the 4 anymore, it must be with the other number, the 81. Log base 3 of 81. That's how we word it. Equals 4. So this is exponential form, this is log form. These are the same thing. Okay? But when I rewrite it in log form, it can help me solve this. Okay? We may come back to that at the end of the problem, or the end of the lesson. Okay. Now, let's try it again. 1/2 is my exponent, 25 is my base, and then it's equal to 5. So, if 25 is my base, then when I write it in log form, 25 is still my base. So it's log base 25 of, well, 25 can't stay with the 1/2, so it must be with the 5. Log base 25 of 5 equals 1/2. Now, there's one more thing that I want to write over here. It's a good way for you in the back of your mind to kind of make sure you're on the right track. Number 3, in log form. In log form, solve for the exponent. Sorry about that. Okay, so in log form you have solved for the exponent. In other words, what's my exponent? 4. When it's in log form, I have solved for 4. 4 is by itself on the equal sign. Now, like I said, remember, usually x is your power, or y, or whatever variable. So our goal is to try to solve for x. Well, when you write it from exponential form to log form, you are solving, you're rewriting it so that it solves for that power, that exponent. And that's a way I could rewrite this. But we're going to come back to that one in a moment. The first important thing that you need to be able to do is to convert these logarithms. Convert it either from exponential form and change it into log form, or start with log form and change it back to exponential form. So let's try that. These are in log form. What is my base? This says log base 2 of 32 equals 5. So my base was 2. So I'm going to start by writing a 2. The two numbers that are together on one side do not get to stay together when you switch it to the other form. So it's not 2 to the 32 power, it's 2 to the 5. And remember, in log form, you have solved for the exponent. So 5 is my exponent. 2 to the 5th equals 32. If I said rewrite this in exponential form, what's my base? A. What's my exponent? C. A to the C equals B. All right, so let's go to the next thing. This is converting back and forth. Now the next thing that we need to talk about is how to evaluate a log. A log has a numerical value, unless there's a variable in it. We'll talk about that in a little bit, not today. But I want to know the numerical value of this. So if I'm asking what is log base 2 of 16, well, I want to know what is that equal to. So it's equal to something. That's what I'm trying to figure out. If I change it to exponential form, that would be 2 to the x equals 16. 2 is my base, x is my exponent. Can you figure out what x is? Well, you could take a calculator, if you don't know it off the top of your head, and kind of figure it out. 2 to the first, 2 to the second, 2 to the third, 2 to the fourth. 2 to the fourth is equal to 16. So x is 4. We could figure it out. Some of these are nice where you could figure out. But look at the next one. 3 to the x. If I said, okay, what is this equal to? 3 to the x equals 48. I have no idea, honestly. 3 to the second power is 9. 3 to the third power is 27. Let's write that one down. 3 to the third is 27. 3 to the fourth is 81. 48 is somewhere in between there. My answer's got to be somewhere between 3 and 4, but I have no idea. It's not something I can figure out on my own. I could try different decimals in the calculator, but that would take me a long time. So that's why we want to learn about the change of base formula. Now, keep in mind that the majority, there's a couple of them that just starting out now, last year and this year, that actually can take a base of 3. But overall, most calculators, you cannot put in a base of 3 or a base of 7. They all have, the ones that have a log button, they are programmed to just be a log base 10. So if you had a log base 10, you could use a calculator. But if you don't, you can't. I cannot put this in a calculator unless I convert it to a log base 10. And that's with the change of base formula. Get it? I'm going to change the base from a 3 to a 10. How do I do that? I use this formula. The basic formula, log base A of B, would be converted to log of B divided by log of A. Hey, what happened to my base? I have no base. I didn't write a base. There's nothing there. Something's missing. It's a 10. I will use blue. All right. Log base 10 of, I don't care, 9. I'll just put a 9 there. This is what we call a common log. You don't have to worry about this too much, but you do need to at least know the main idea, which is that when you have a log of base 10, it is a common logarithm, so you don't have to write the 10. Basically, that's what it comes down to. You know how when we have an x squared, there's no number in front of the x because it's an understood 1. When I write a square root symbol, I don't have to write a little number in the radical because it's an understood 2. A square root has an understood 2 in the little radical. Well, a 10, if it's not there, it's understood. So I actually don't even have to write this 10. The log base 10 of 9 is exactly the same as log of 9. So if you see something like this and it's missing a log, it's understood to be a 10. Your calculators are programmed to deal only with a log base 10. So if I can convert, let's say, a log base 3 into dealing with a log base 10, then I can use a calculator. So let's try this. Log base A of B is equal to the log of B, there's a base 10, divided by the log of A, my base. The base is always the one that goes on the bottom. So let's rewrite this one. Log, let's leave that as an example, base 3 of 48. I could put that in a calculator. Let the calculator find the answer for me. I would first take the log of 48 and divide by the log of 3. And I would have my answer. I should have grabbed one. I wonder if mine will work. Hold on. Yay, calculator's right there. So you have to be very careful, though, and enter this in correctly, because if you don't put the parentheses in right, you could get a wrong answer. So I doubt you can see this, but I'm going to hit the log button, which is over here, and I'm going to enter 48. And I'm going to close my parenthesis. I want the log of 48. I'm going to hit divide and enter in the log button, 3. Log of 48, divide by log of 3. I hope you can see that. I'm winging it. All right, when I hit enter, I get 3.52. 3.52. Does that make sense? Didn't we say earlier that it's got to be somewhere between 3 and 4? And sure enough, it is. Yay! So we have our answer, and that's all you have to do. So let's try one more. If I had log base 2 of 112, I don't know what that is, but it's going to be a bigger number at least. What am I going to enter in the calculator? Log of 112 divide by log of 2. That I can put in a this I can't put in a calculator, but I can put this in a calculator. I can just hit log of 112 and then close the parentheses and then divide by log of 2 and close my parentheses. And what do I get? 6.81. 2 decimal places. Okay. Now, for those of you who don't have a graphing calculator at home and you want to do your homework, I found on my own smartphone that there are great apps out there, free. I actually just did a search for graphing calculator, and I found a great one that's right there. It's an app on my cell phone right now that I can do logarithms. Tip, when I had it in scientific calculator mode, I believe it will also do it in graphing, but a scientific calculator, if you don't see the log button, I had to hit the shift key and it suddenly came up. But that can be a help. Or on the internet, I'm sure you can find apps or websites that have scientific, that's the better one, scientific calculator, even graphing calculators. Okay, so that can help you with that. Worst case scenario, if you don't have access to a calculator to help you get the log values, at least set it up and get it going so that you can show you know how to do it. All right, there's logarithms. Good luck.